Hi, in this video we're going to work a little bit more in the chain rule. So for that we have certain examples and we can address them in very different ways. We can try and classify the functions that are creating the composition and then use the general rule that we have for the chain rule, or we can just simply go ahead and use the Leibniz notation and do the chain rule in that way. So let's remember we can have this option f of g of x, and then the derivative is f prime of g of x times g prime of x, or we can consider that y is equals f of u, and then u is g of x, and then calculate the derivative dy dx as dy du times du dx. Okay. So let's do a couple of examples for each of these formulas in this case, and then in the next couple of examples we'll get rid of this and we just plainly find what the chain rule is. So for the first one we have y equals square root of 5x squared plus 1. So given that, we can say, well, this is like the composition of the function f of x square root of x and the function g of x 5x squared plus 1. So thinking of that, if we compose and we do this, this will be f compose g, and then therefore y prime is just going to be 1 over 2 the square root, which is the derivative of f, right, composed from 5x squared plus 1, and then times the derivative of g of x, g prime, which will be 10x. Similarly, for d here, I can say, oh, okay, so f of x is going to be the function e to the x, and g of x is going to be 3x minus 2. And so this e to the 3x minus 2 is the composition f of g of x. And now if we want to find y prime, which is f prime composed gx times g prime of x, then we're just going to find out that it's the same exponential composed in g of x times g prime of x, or e to the 3x minus 2 times the derivative of 3x minus 2, which is 3. And so that'll be the end result. Now that's really easy to do in this way. Now this is using this type of approach. Now let's use a different approach for E and F. So in E and F, well, in E we can pretty much rearrange the way that the function is being written. So we can write that as x squared plus 1 to the minus 8. This is pretty much prime for the use of the power rule that we mentioned before. Y prime will be minus 8 x squared plus 1 to the minus a minus 1 times the derivative of this, which is 2x, right? So that's using the power rule. But we can also say, okay, so apparently I can think of y equals f of u as u to the minus 8, and I can think of u equals g of x as x squared plus 1. And so in that way, if I do du dx, that's going to be 2x, which is the derivative of this. And if I do the y du, is going to be minus 8 u to the minus 9, right? And so calculating the y dx, which is the derivative, is the product of these two things, the y du dx. So this is minus 8 u to the minus 9 times 2x, or minus 8 x squared plus 1 to the minus 9 times 2x. So by any of the two approach, I reach the same conclusion. Okay. Finally, the only one that I'm missing is y equals cosecant of 7x. So let's go ahead and do this one below. Y equals cosecant of 7x. So if we follow y equals f of u, we can think of this as cosecant of certain function u, where u is the function g of x equals 7x. Okay, so the y, the u is going to be minus cosecant of u cotangent of u, which is the derivative of cosecant. And if we do the u dx, is going to be 7. So now the derivative, the y dx, is the multiplication of these two things. And if, of course, then we go back, okay, u is 7x, so minus 7 cosecant of 7x cotangent of 7x. Okay. That's the use of the chain rule on this case. Now for the next set of exercises, we're gonna mix and match with some of the other properties that we have in past, powers, product rules, quotient rules. So we're going to just do chain rule directly without necessarily going into details of who the functions are and the approach that we use. Okay. So for the first one, for A, we have a product rule here clearly, and the chain rule is in the exponential. Notice that this is an exponential to the minus 3x. So when we're doing the normal derivative, this is going to be mainly a product rule. So this is 6x to the 5 times e to the minus 3x plus, and then x to the 6, and then the derivative of e to the minus 3 to the x, which is e to the minus 3 to the x because it's an exponential, times the derivative of the function inside, which is minus 3. Okay, so that is the solution for A. Now for B, notice that we have the function y equals sine of x e to the x. So the first function is not going to have an issue. When we take the derivative of sine is cosine, and it's cosine of the same thing. But now the stuff inside, which is the chain rule, it is going to be a product. So this is cosine of x times 1 e to the x plus x, and then e to the x. Okay, so overall this is just cosine of x e to the x times e to the x plus x e to the x. Okay. In C, we have a composition, so we have power here going on that we can express to e to the minus 5x squared plus 9 to the 1/2. So there is a power situation, and then the function inside also has a chain rule because you have an exponential that is more complicated than usual. So if we do y prime, now we get 1/2, and then let's do this as a power. We're going to do this same thing, and 1/2 minus 1 is minus 1/2, and now times multiply by the derivative of the stuff inside. Notice that the derivative of 9 is 0, so the only part that is going to care from the function inside is going to matter is the derivative of this exponential, which is the same thing, right, because it's an exponential, times now the chain rule, which is the derivative of this minus 5x squared, which is now minus 10x. Okay. So overall, if I simplify this minus 10 with this 1/2, is going to be minus 5x e to the minus 5x squared divided with the square root of e to the minus 5x squared plus 9. Okay. Now let me work a d over here. So we have y is equals sine of x squared cosine of x cubed. This is a traditional product rule, but we have a stuff inside. We have functions inside, so that produces a chain rule. So y prime is going to be, okay, derivative of the first one, which is going to be cosine of x squared times the derivative of the inside to x times cosine of x cubed plus, and now sine of x squared, we don't take derivative in there, and we do take derivative of cosine, so minus sine of x cubed, and then we take the derivative of x cubed, which is going to be 3x squared. Okay. This cannot be simplified further, just a little bit maybe, but there's not a lot of simplification to do. Now, last but not least, we have this quotient situation here. So we have y equals cosine of 10x over e to the 4x plus 1. So this is a traditional quotient rule. And the problem is the function, they're going to have some chain rule involved. But let's state first the quotient rule. So we have the derivative of cosine of 10x times e to the 4x plus 1 minus, and then the first functions without derivative of the second, e to the 4x plus 1, and then we divide by the function below a square. Okay. At that point, the quotient rule is stated, and the only thing left to do is to take the derivative. So derivative of this is minus sine of 10x times the derivative of the function inside, which is 10 times e to the 4x plus 1 minus cosine of 10x, and then the derivative of this. In this case, we have e to the 4x, so the derivative of that is e to the 4x again, times the derivative of 4x, which is the function inside. The derivative of that is 4. The 1 has a 0 derivative, so we're done at this point. Alright, and that's the video showing some extra examples of the interactions between chain rule and the other operations.